Recording in progress.
So we are looking at refraction, right? What's the difference between the reflection and refraction? Reflection is, what is reflection? Hari? Reflecting of light. Reflection is reflecting of light. Bending of light. Hari, you're not studying at all. Reflection of Everything is good with you? Why you're not focusing? I'm not asking something so complicated, no. Just a basic things only I'm asking. Just a simple reflection. You are saying refraction, bending of light. Rohit, what's reflection? So when the light will bounce back, sorry. When the light is traveling from one medium to other medium, that medium is fully reflective. Fully reflect. So at some medium, light can reflect also, refract also, right? Right? It can happen both. But if it's a fully reflective medium, it will be fully reflected. But if it's a fully transparent medium, then if it's an opaque medium, fully opaque means light will be reflected back, right? Means there is a coating, reflective coating. So if it's a fully transparent medium, then what will happen? The entire light will refract. But if the medium is in between, it's not a fully reflective, it's not a fully refractive, then what will happen? Some of the light will reflect back, some of the light will refract. Okay. So it depends on the material property. That's a material property. So that is gone by refractive index. Material property gone by refractive index. So what's the law of reflection? Just hear what they are saying, okay? Just understand. What is the law of reflection? Normal, normal to what? Normal to what? Normal to point of incidence. Normal to the surface at the point of incidence, right? Normal to the surface at the point of incidence, right? So just with the point you can never define the normal. Normal is always with respect to the surface. only we can define the normal to the surface, right? You cannot define normal to the line, or you cannot define normal to the point. So you can only define normal to the surface. Okay, so normal to the surface, only you can define normal to the surface. So we are measuring the normal at that particular point of incidence. So where that rays, yeah, so touching the surface, that's the point of incidence. So we are measuring the normal there. So these all these are the three things, right? So what the law of reflection has three points. What is the 3 point? What are the 3 points? One is angle of incidence equal to angle of they will they will lie on the same plane. 2 points. They will lie on the same plane. So that says as angle of incidence equal to angle of reflection. So angle of incidence always will be measured with respect to angle of incidence or angle of angle of reflection or angle of refraction. So they will be always measured with respect to the normal. They will always measure with respect to the normal, right? So if the angle of incidence equal to 0, then what will happen? Sorry, the ray will again trace back again the same direction, right? Then angle of incidence equal to angle of reflection. When this will happen? So we have 3 cases something, right? 3 or 4 cases. So when the ray is passing through the center of curvature, then it will again trace back the same path, because the angle of incidence equal to angle of incidence equal to 0. The angle of incidence equal to angle of reflection, that's always true, right? So only angle of incidence equal to 0, then it will again retrace back the same path, right? So how to draw the normal in case of spherical mirror? So always to draw the line, how many minimum points you need? To draw the line, minimum points you need. No. In general, if you want to draw a line, I'm not asking with respect to 2 points, right? If you have the 2 points, you can draw the line, right? If you have the 2 points, if you connect the 2 points, the line will come. So in order to have the normal here, line, normal is a line, right? So how to get the normal line? What are the 2 points? One is the point of incidence, other is the center of curvature. Always the normal will passes through these 2 lines. Okay, so what will change in the mirror? Always the point of incidence will change, but the center of curvature will never change, right? For the given particular mirror, always the point of the center of curvature is same. Only the angle of incidence will change. So that's why normal will change according to the point of incidence. So always the normal must pass through the center of curvature. Okay, so then you measure the angle. What is the angle of incidence? What's the angle of reflection? That way you can measure it. Okay. So what about the law of refraction? Transparent media. Not the rays, not the angle of incidence, but the rays, right? The incident ray, the refracted ray, and the normal they will always lie on the same surface, right? Sin I by sin r equal to constant. So which is nothing but the Snell's law. Snell's law is equal to sin I by sin r equal to constant, which is equal to ratio of the refractive indices, right? So Ni sin theta equal to Nr sin theta r. Okay, here theta is angle of incidence, theta r is angle of refraction, right? Angle of refraction. So Ni equal to Ni equal to refractive index of the incident media, right? Nr equal to refractive index of the refractive media, right? Okay, so that's a Snell's law. The constant value is called refractive index of the second medium with respect to the first means N2 by N1. N2 is refractive index of the second medium, N1 is the refractive index of the first medium. So sin I by sin R equal to N2 by N1. So otherwise N1 sin theta sin I equal to N2 sin R. So this is the refractive index of the this is the refractive index of the medium 1. This is medium 2. So let's say I'm traveling, not I'm traveling, Ray is traveling, right? Ray is traveling from, so it's a glass slab, okay? It's a glass slab, and the ray is coming like this. So what is here medium 1? So it's a normal. So what's here? Let's say take this as a glass slab. Glass slab. Okay. So what is here medium 1? Medium 1 is air, right? Medium 2 is glass. So this is interface 1. For interface 1, medium 1 is air, medium 2 is glass. Let's say there is also one more interface, no? So for this interface, what is the medium 1? Medium 1 is glass, medium 2 is air. Okay. So medium 1 is always where the incident ray lies, right? Medium 2 always where the refracted ray lies, right? So what will happen when the rays are traveling from, how to define the rarer medium and denser medium? What's the rarer medium, what's the denser medium? How to define them? Huh? Rarer, denser. So means it's a comparative, right? It's not absolute thing. When you say rarer or denser, it's a comparative. Always we need to define with respect to other medium. Okay. So if the light is traveling from rarer to denser means the refractive index of the medium 1 is low. So means N1 less than or equal N1 less than N2. If it is rarer to denser means N1 less than N2. Denser to rarer means N2 or N1 greater than N2, right? First case N1 less than N2, second case N1 greater than N2. So this is rarer or denser with respect to always define with respect to other medium. So it's not a absolute. Okay. So here also consider a ray of light traveling from medium 1 to medium 2. So I'm referring to figure 9.11. The same, yeah, same section or different section? 9.11. Okay. So consider see the figure. You have the text here. Hari. So what's the figure number for you? 9.10, 10.10. Show me the figure. Okay. That's a 10 point. Hurry, your paper is going somewhere. I'm taking. So here let v1 be the speed of the light in medium 1 and v2 is the speed of the light in medium 2. The refractive index of the medium 2 with respect to medium 1. The refractive index of the medium 2 with respect to medium 1 is given by the ratio of the speed of light in medium 1 by speed of the light in medium 2, which is equal to n to 1. So n to 1 means refractive index of the medium 2 with respect to medium 1. Is that right? So first in the subscript, let's say when you say n to 1, so refractive index of medium 2 with respect to medium 1. If you say n1 2, refractive index of medium 1 with respect to medium 2. Okay. So n to 1 equal to v1 by v2. So the refractive index and the so velocity they are inversely proportional, right? So that's why the change in shift v1 by v2. Okay. What is the formula for n equal to c by v, right? So c is constant, v is, so here n is inversely proportional to velocity. So that's why n to 1 is v1 by v2, not v2 by v1. Okay. Refractive index of medium 2 with respect to medium 1 is not v2 by v1 but it's v1 by v2 because it's inversely proportional to the velocity. That's why, okay, it comes up. Okay. So if it is with respect to refractive index of medium 1 with respect to medium 2 will be v2 by v1. So if medium 1 is vacuum or air, then the refractive index of medium 2 is considered with respect to vacuum. This is called absolute refractive index of the medium. This is absolute refractive index of the medium when medium 1 is vacuum or air. Then we can simply say that it's n2. No need to keep 1, n2 1. Okay, because the medium 1 is vacuum or air, right? So in that case, if medium 1 is vacuum or air, you no need to have two suffixes. You can simply say it's n2 because medium 1 is air. Only in that particular case we call it as a absolute refractive index. Otherwise, it's a relative refractive index. So always, so in that case, n is defined as c by v, right? C by, because what is the medium to refractive index? C. Sorry, what is the medium to velocity? Because medium 1, right? n21 equal to what is v1 by v2, right? So what is v1? V1 here, v1 is refrigerator, huh? Then you move it a little bit side. No, why you are so much observing? Ask her to. So much space is there. You move, Vijay. You properly sit, Vijay. Properly sit and move. So why here nm or medium refractive is the medium equal to c by v? So you are here only, right? What is the why refractive index of medium equal to c by v? So when we say it's absolute refractive index, and the medium 1 is air, vacuum or air. So for vacuum or air, what is the velocity? C. So generally n21 formula is v1 by v2. So what is v1 here? C. V you can take simply as v. So n21 can be written as just n2. 2 is nothing but the refractive index of the medium, some medium. So that's why nm equal to c by v. Rohit, got it? Why nm equal to c by v? So v2 you can take it as v, then V1 is C. So in that case, you can call it as absolute refractive index of the medium. So which is nothing but NM, that medium, particular medium. Okay. So that's how we got the absolute refractive index of the medium as NM. So what N21 is? Refractive index of medium 2 with respect to medium 1. N12 is refractive index of medium 1 with respect to medium 2. So when medium 1 is aired, then we can call it as absolute refractive index. So which is you can take out that subscript. Just you can say that refractive index of the particular medium NM. M is medium. Okay. Which is equal to NM equal to C by what is C value? 3 into 10 power 8. What are the units? Meter per second. Note down, hurry. See what's the C value? 3 into 10 power 8 meter per second. So always V will be less than or equal to C. C will be the maximum, right? So it will be less than or equal to C. In that case, what will be N value? It will be always greater than or equal to 1. Right? It will be always greater than or equal to 1, not C. Huh? Yeah, V is always less than or equal to, not greater than or equal to. So, but refractive index will be always greater than or equal to 1. So here refractive index is given for some particular media. So what is the plural for medium? Medium is singular, right? Plural media. What is social media? So social media. So media is plural, right? Medium is singular. So if you take air, it is for glass. So here diamond has a refractive index is how much? Diamond. Hurry. 2 point. So which is much denser than glass or whatever the media is reported here. The refractive index of diamond is much higher. So the speed of light in diamond will be much lower because refractive index is much higher. Then what will happen? So if the light is traveling from lower to denser, the light will always bend towards or away to the normal. Bend towards the normal, right? Hari, do you have water? Rohit? Refractive index. So what they are saying in this more to know the ability of medium of refract light is also expressed in terms of its optical density. Optical density has a definite connotation. It is not same as the mass density. So optical density means optically rarer or optically denser. Optically rarer. It is also called mass density. Mass density means with respect to how the atoms in the material are packed, right? How closely they are packed. That has to do with the mass density. So this optical density has to do with the refractive index, whether it's optically rarer or optically denser. So when light is traveling from denser to rarer, it will speeds up and bends away from the normal. If it is traveling from rarer to denser, it will slow down and it will bend towards the normal. The speed of light is higher in rarer medium than denser medium. The refractive index is lower in rarer medium compared to the denser medium. So this optically denser or optically rarer. So today we see refraction of the spherical lenses, refraction by spherical. So we look at some ray diagrams, right? Refraction by spherical. Sorry, spherical lenses. Spherical lenses. So these are all spherical lenses only. So that's why we have the two sides, right? One is a spherical, the other is a cylindrical. So that's a different. Cylindrical is different. Spherical, we are concentrating only here spherical lenses. So does anyone of you have a laser light? Some color green laser? Not now, but do you have? Whom you have? You have? Hari, can you bring next class? We have some glass slab, some transparent glass slab. Then we can see the refraction. How the refraction will happen. Can you look for glass lab? Try look for the glass lab. If you find, bring it. Next class means next Wednesday. Just try for it, not a compulsion. Okay. If you find it, then we can see the reality how the refraction will happen, and that will be interesting to see. You can also try if you get physics. Oh, you can take it for one. We can't take it, no. Sorry. Just check it if you get it. Then we can see like here they kept the glass lab, no. We can see how this race will. What happened? I didn't see anything. So we can see how this one will happen. Okay. Or if we can get this one something like this also, we can the lens. Okay, so let's look at the convex lens. What is this point O? Optical center, huh? So what is here M? This is point M. This is N. Mn is aperture. Mn is called aperture. So let's say for this one, consider this is the center of curvature. Let's say C1. Sorry, what is this one? So this is the, for this one, this is the center of curvature. See. Okay. So what will be this one here? F1 will be middle of the point O and C1. F2 will be, okay. So now if the light is traveling, what is this one? This is called principal axis. Principal axis, right? So if the light is traveling along the principal axis, what will happen? It will just pass through the same, okay, right? Why? Because I equal to 0, so sin I equal to 0, then sin R equal to R is equal to, right? So if the light is passing, so if the one more parallel ray, let's say parallel ray, then it will go through the focal point. It will pass through the, this is the incident ray, this is the refracted ray. Okay. So if the light is traveling, again one more parallel ray, then what will happen? This will also again pass through the focal point. So all the parallel rays will pass through the. So what does it mean parallel rays? What does it mean by parallel rays? So means the object is at infinity. Parallel rays means object is at infinity. Then all the rays will pass through the focal point. So always you need to indicate these arrows properly. Okay, you should keep the arrows. It will show the direction. So if it is a reflection, then you need to show back. Means which direction they are going, right? So in case of concave lens, so concave, so here the converging will happen, right? All the rays will converge it. It's called converge. Converged focal point. In case of concave lens, diverge. So like they are kind of diverging from, or they are, yeah. Let's say take this as a concave lens. For this one also point optical center, optic center. This is the, so optic center is O, and this is the principal axis. Now take it as this is a C1, F1, C2. How to measure C1? How to, sorry, how to find out C1? Sorry, center of the, so this lens, right? The left one, okay, that will be C1. The right one will be this one, C2. So here C1 will be this one, right one. C2 will be left. Okay. So here, if the parallel rays are parallel, then if the light is passing through the principal axis, means it will go through the same. There won't be any change. Okay. If the light, one more parallel ray is coming up, means so it will diverge. So appear like it is passing from the focal point. So here also it will diverge, appear like it will passing from the focal. Okay. So the image formed here will be. So here it's a real, right? Here it's a real image. So here it will be virtual, right? Because it will appear like a coming from there, but it's not exactly image is there. Yeah, it appears like coming from there. So we see image formation by lenses. Image formation by lenses. So here there are how many cases were there for the. So here also if the what's happening with you, Vijay? So if the rays are parallel, then for the convex lens, they will pass through the focal point, right? So for the concave lens, they will appear like they were diverging from the focal point. Okay. So if the ray is passing through the focal point, then it will be parallel to the principal axis. Okay. So if the then it will be parallel to the principal axis. Okay. So this is F1, this is F. What will happen in case of concave? Concave. Rohit? So let's say this is F2. If it appears like coming from F2, then it will be parallel. The incoming ray is like this, then it will be parallel to the principal axis. So here it's not passing really. Yeah, it's a virtually appearing like passing through the passing through the focal point F2. Okay, the virtual, it's not a real. So in that case, it will be parallel. Okay, so this is the difference with respect to convex and concave. So what will be the third case? Optical center, optic center. Then it will just pass. It will just pass through without any deviation. Okay. So what will happen here? Again it will pass. Okay. So using these three cases, we can draw the ray diagrams for the image formation of the lenses. Okay. So for each case, for concave case, how many for concave mirror? How many cases we had? Concave mirror case. Concave 6, right? Concave 6. Concave mirror case 6 cases. Convex mirror case 2 cases. So say here it will be opposite. Convex mirror case there will be 6 cases. Concave mirror case it will be 2 cases. Okay. So the similar thing you can just compare from mirror to lenses. Okay. So what will the first case? Image formation. Object is at infinity. Okay. C1, F1, F2, C2. So if the object is at infinity, then they will always focus at focal point. Image will be formed at okay. So what is Mn here? Aperture. So what's happening? If the object is at infinity, the image formed is at highly diminished point size, and it is formed at F. It's a real and inverted. So actually it's a point size, so we cannot directly say it's inverted or direct, but according to the convention we say that. When it's a point you can't say it, no, whether it's up or down, right? Just a point lies on the principal axis. So what about the case 2? Object is at C. F2, C2, F1, C1. So let's say the object is like this. Oh, sorry. So let's consider beyond. Yeah. So next case is beyond C. Yeah. So consider somewhere here. Okay. This is C. So it's between C and infinity, right? So then, so how can you draw now? What are the two rays we can draw? One will be passing through the optical, one ray will be passing through the optical center. One ray is passing through the optical center, other ray is parallel. Then it will go through F2. It's F2. Yeah. Okay. F2. Right. Then it's forming. Where is the point? Is the image is forming now between C2 and F2, right? Between C2 and F2. So let's say it's a it's a it's B. So this is a B dash, it's a A dash. Prince, you're focusing or so what is this one? This will be U, this will be B, right? So what's happening here? Image is if the object is between C and F, between infinity and C, then the image will be formed at between C and F, F2 and C2, not highly diminished. Diminished. Uh, Inverted. Inverted. Real and inverted. Yeah. Real and inverted. Real and inverted. Diminished between C2 and F2. Okay. Case 2 is between infinity and C1. Yeah. Case 3 will be case 3 will be so if the object is at exactly at the C1, then so parallel ray, then it will then it will go through like this. If it is this one, then it will pass through F2 and then meets at C2. Okay, right? So let's say it's a and B. This point will be B dash. It will be A dash. So this is the incident. This will be refracted. Okay, this will be M N. Okay, so now what are the so now the case is at it's a object is at C1. So the image will be formed at C2, same size, real and inverted. Okay. What about case 4? Case 4 between C1 and F1. Between C1 and F1. So in this case, this will be Mn. Mn is O is optic center. This is F1. This is C1, F2, C2. Now the object is between. So what are the two rays we can consider here? One is passing through the optical center, and other is parallel. Parallel will pass through F2. Yeah, beyond C2, right? Let's say we consider this A, B. This will be B dash and A dash. Okay. So now what about the image? Image will be between C2 and infinity, beyond C2. Yeah, beyond C2. That also can write. Yeah, beyond C2. And real and inverted, enlarged. Right? What is the case 5? at if the object is at f1. So this will be dual to the case 1, right? Dual to the case 1. So if it's infinity, then the image will be at f, right? If it is f, object will be f, then image will be at the n. So the case, this is the dual. That's called dual. So this is O, f1, c1, f2, c2, m, n. Okay. First of all, you need to mark all the points. Okay. Then now exactly at the A, object is here. Okay. Now, so what are the two rays that you can draw? Center and again the same rays, right? Center and okay. And these two rays are exactly parallel. Okay, these two rays will be exactly parallel. So parallel rays will meet at infinity. Okay, so what are the image properties of image? So image will be formed at infinity, highly enlarged, real and inverted. Okay. So all cases this is a real and inverted. So only the next case, only that is virtual. Only case 6 is virtual. So in mirror thing also only case 6 is visible. So that's the concave case. This is the convex case. Okay, that you need to correlate both of them, then try to understand. Okay. So what will happen here in case of now what is the case? Okay, now object is at a okay. So now one ray is passing through the optical center. Okay, parallel. They will diverge, right? Yeah, you can see that is going upward, this is going down. Okay, they will see like they all meet like some particular point. Okay, I think okay. So now what's happening? It's a let's say if you take it as A and B, this is B dash, and it will be A dash. So it's a virtual, right? It's not a real. Virtual. So the image is formed beyond C. Yeah, beyond C. Good. Beyond C1. It's a enlarged. Virtual and direct. Okay, these are the cases. So we'll just finish off this 2 cases of concave also. Okay, just 2 cases only, no? Okay. So for concave, there are only 2 cases. Concave lens. What are the 2 cases? One is at infinity, other is infinity and any point between, yeah. Hmm? So for the parallel thing, what will happen? Infinity means they're coming parallel, then they are seem like coming from here. Okay, this is the diagram, right? Mn. Okay. So here they will. It's a virtual, right? So image is formed at f1, not f2, right? f1. So it's a virtual erect. Okay, erect only, right? Okay. Erect and highly diminished. Okay. So next case will be between optic center and f1. Case 2 will be between infinity and optic center. Between infinity and optic center. Okay, anywhere. That's why only two cases now. So now let's consider between, we can consider anywhere, but I'm considering between the C1 and F1. Then one must pass through the optical center, other through the parallel, diverges, right? And what's happening? So here they are meeting here, right? They appear like meeting here. So it will be A, B, then it's a B dash, A dash. Okay. So it's a Mn here. So now what are the images formed at? Formed between O and F1, yeah, and then it's a diminished virtual erect. Okay. So we'll finish this chapter in the next class. Okay. So we have that that lens formula and some problems and power of the lens and all. So we'll finish the next class. Okay. So these ray diagrams are clear, right?